Welcome back, Pre-Calc. We're going to continue with sequences, and you can tell that now we're finally getting into the definition of an arithmetic sequence, and you can see it's defined recursively right here, where you need to know the first term, and then you can figure out the next term. If you notice in a few problems, we could actually start with like a middle term, and we can work backwards as well. This D, as I showed you before, is representing the common difference. That's what the D stands for. Notice it can be positive or negative. If we have a negative D value, it just means we're going down in value. And we can see that in the very first example. Now 1A, they tell you that the first term is 2. So then if our common difference is adding 6, well, if we add 6 to 2, the second term would be 8. If we add 6 to 8, we'll get 14, and adding 6 to 14 will give me 20. And yeah, we can stop right there because we're given the next three terms. If you need any help with this, and I hope the first lesson helped you out, you can see how a sub 2, n is 2, that means take the 2 minus 1, so a sub 1, and add 6 to it. So that, I think that might help you understand why we add 6 to find the second term. And so to find the third term, you take the second term and you add 6 to it. And hopefully my arithmetic is correct here. Okay, so moving on to the next one. We know that the first term is 8. It tells us right there. And the common difference is minus 4. It's a negative 4, so we're going down by 4. So the second term would be 4. 8 minus 4. 4 minus 4 would give us 0. 0 minus 4 is negative 4. So there's our next three terms. Maybe we'll even put a box around the next three terms as the directions tell us. We can also have patterns that are adding fractions. Not a big deal. So as we look at that, we can, okay, so the first term is 3 halves. So adding 1 half, the common difference, to 3 halves, will give me 4 halves, but we like to reduce our fraction to be 2. 4 over 2 is 2. So then we're at 5 halves next, and then 6 halves would be 3. So there's your next three terms. I hope you can tell the pattern going on. So as we move on to the next problem, just notice that we can also do this with imaginary values. I'll change colors just to emphasize. So the first term is negative 3 plus 5i. Well, our common difference is adding 6 and negative I. So the second term, so a sub 2 would equal negative 3 plus 6 would be 3. 5i minus 1i would be 4i. So then a sub 3 is again adding 6 to the real part. So that would be adding 6 to 3 would give me 9. And subtracting 1i from 4i would be 3i. And then the fourth term, should have wrote smaller, but that's okay, add 6 to the real part, so we're at 15. And add negative 1i, or just subtract 1i from the imaginary part. That's from right there. Gives me 2i. So as you look at your options, option 1 is what we want. And apparently I messed up printing this off, as that little line fell off. So you have option 1 on that one. Sometimes we, well, I think what we're doing on this next one is trying to get you to walk you through the thinking process involved into answering these types of problems. So in this problem, we have a recursive definition with the first term is 5. I like to write out the first term. You don't have to. But if our pattern's adding 3, then the second term would be 8. The third term, if we add 3 to 8, would give us 11. And the fourth term would be adding 3 to 11, so we're at 14. So those are your next three terms. So then as we look at the pattern, it's asking you how many times was 3 added to the first number, 5. So just to repeat, the D in the problem was 3. A sub 1 is 5. In order to figure out the fourth term. Well, if I go back to this, 3 was added once, twice, 3 times to figure out the fourth term. So that's our answer. It was 3 was added 3 times. And what's the pattern between a sub 4 and 3, well, the pattern is that it's a sub n and the 3 is 1 less than that. And I could ask you that for any problem. Is if I'm asking you for a sub 50, then we would add the number 3. This is confusing, that's 3, then 3 times. We're adding 3 49 times. And what's the pattern between 50 and 49 is it's 1 less than that. So how can we come up with the nth term of an arithmetic sequence? Let me switch back to the important, just a different color. Is you always start with the first term, and you take the common difference, and you multiply by n minus 1. And this formula works for any nth value. Let's go back to 14 for a second. 14 was a sub 4. That was the fourth term in that sequence. The first term was 5. The common difference was 3. And I need to multiply. I'm plugging 4 in for n. Well, 4 minus 1 is 3. Is it true that 5 plus 9 equals 14? Yes, it does. So if I wanted you to figure out the a sub 50, which I guess I should have done over here, but I just didn't. It would be 5 plus 3 times 49. And where does 49 come from? Well, 49 is 1 less than 50. So if I used a calculator, I could just type that out. Oops, didn't realize my calculator was still here. 5 plus 3 times 49, 152 would be that correct answer. And that's the formula that we were supposed to figure out from section 1 that I told you I would just tell you the formula later on. So in this problem, now I can ask you certain questions like, if I give you the first term and the fourth term and it's arithmetic, could you figure out what a of 2 and a of 20 are? Now there's a lot of different ways of doing this, so I'm not going to tell you have to do a problem a certain way, but it's based off of that formula, a sub n equals a sub 1. And sometimes what they'll do, because addition's commutative, they might write, n minus 1 times d. Multiplication's commutative. We can switch the order around. So what you might see is, based off of this statement and this statement, that you could say, okay, well, if a sub 1 is 6, I can replace that right there into my equation. And I'm going to just set a sub 4 right here, and that's telling me that n is equal to 4 in my equation. Well, I don't know what the common difference is yet. Now, I'm well aware you guys are smart enough you could probably figure out what the common difference is in this problem. But what I'm going to do instead is I'm going to replace a sub 4 with 18. So 18 is equal to 6 plus 4 minus 1 is 3 times d. So now I can subtract 6 over. And if I divide both sides by by 3, I get d is equal to 4. So why would I go through that process is now I can use this formula and figure out what a of 2 is. My a sub 1 is still 6. I'm going to replace 2 in for n, and now I know the common difference is 4. Well, now I think I can quickly figure that out, that 1 times 4 is 4 plus 6 would be 10. So that's your answer for a subscript 2. I can do the same thing for a subscript 20. Now that I know that the first term is 6, I'm going to replace 20 in for n and replace 4 in for d. And I'm just going to use a calculator. So I'm looking at 6 plus 19, because that's 20 minus 1 times 4, to give that answer of 82. Now, I'm not trying to rush through these notes, so I think I'm going to stop right here and we can talk about geometric and the geometric in the second video.